The distance in degrees north or south of the equator. Latitude. Latitude is an imaginary line that measures how far a location is from the equator. Imagine you're trying to figure out how far you are from your favorite coffee shop in the city. Just like you measure the distance to understand how far you are from the shop, latitude helps us measure how far a location is from the equator on Earth. In this analogy, the coffee shop represents the equator, the city map represents the Earth, and the degrees of latitude are like the distance markers that tell you how far north or south you are from the equator, just as you measure blocks or miles to the coffee shop. The distance in degrees east or west of the prime meridian. Longitude. Longitude is a geographic coordinate that specifies the east-west position of a point on Earth's surface. Imagine you're trying to find your friend at a crowded concert, but you only have a vague idea that they're somewhere near the front stage. This is similar to how longitude helps us pinpoint locations on Earth by telling us how far east or west a place is from the prime meridian, much like narrowing down your friend's position relative to a fixed point like the stage. Just as you might use landmarks to locate your friend at the concert, longitude uses the prime meridian as a reference line to specify a precise location on the globe. Explains the meaning of symbols used on a map. Map legend. In science, a map legend is like a key that helps you understand what different symbols on a map represent. Imagine trying to assemble a piece of flat-pack furniture without any instructions, just as the assembly guide provides meaning to various parts and steps, helping you understand how each piece fits together. A map legend explains the symbols used on a map, guiding you through unfamiliar terrain. In both scenarios, the guide or legend acts as a translator, turning seemingly random symbols or pieces into a coherent, understandable system that allows you to navigate the task at hand, whether it's building a bookshelf or finding your way through a city. A line on a topographic map connecting points of equal elevation. Contour line. A contour line shows areas at the same height above sea level, helping to visualize the 3D shape of the landscape on a flat map. Imagine you're trying to organize your messy closet, where everything is piled up at different heights. Just like how you might sort your clothes by creating layers of similar items at the same level, contour lines on a map connect points of equal elevation, creating a visual layer of height. In both cases, whether it's organizing clothes or mapping terrain, the key idea is grouping similar levels together to make sense of the chaos. Clothes at the same height in your closet, and land at the same elevation on a map. The difference in elevation between two contour lines. Contour interval. In science, a contour interval is the vertical distance or difference in height between successive contour lines on a map, showing the slope of the terrain. Imagine you're climbing a staircase where each step is a different height, making it tricky to walk up smoothly. This situation is similar to reading a topographic map where the contour interval represents the difference in elevation between two contour lines, much like the varying heights of each step. Just as each step height tells you how much you need to lift your foot to reach the next level, the contour interval tells you how much elevation changes between lines on a map, helping you understand the terrain's slope and steepness. On a map, the heavy contour line labeled with the elevation, index contour. An index contour is a thicker line on a map that shows elevation and helps you easily identify height levels in terrain. Imagine you're trying to navigate a crowded concert and you spot a friend wearing a bright, easily identifiable hat. Just like that standout hat helps you locate your friend in the sea of people, an index contour on a map acts as a standout line that shows you a specific elevation in a sea of other contour lines. Just as the hat helps you find your friend quickly, the index contour being a heavier and labeled line. helps you quickly identify key elevation levels on a topographic map, making it easier to understand the terrain. A line running north to south around the center of the Earth. Prime meridian. The prime meridian is the imaginary line that divides the Earth into the eastern and western hemispheres. Imagine navigating through a crowded shopping mall where you need a central point to orient yourself and decide which direction to take for the various stores. Just like needing a central reference point in a mall, the prime meridian serves as a central line for navigation and orientation on the Earth. In this analogy, the shopping mall represents the Earth. The central point is the prime meridian, and the various stores symbolize different locations across the globe, all measured in relation to this central line running from the North Pole to the South Pole. A line running east to west around the center of the Earth. Equator. The equator is an imaginary line that divides the Earth into the northern and southern hemispheres. Imagine trying to evenly distribute frosting around the middle of a round cake without missing any spots. Just like trying to get that frosting perfectly even, the equator is an imaginary line that wraps around the widest part of the Earth, ensuring a symmetrical division between the northern and southern halves. In this analogy, the cake represents the Earth, the frosting line is like the equator, and the act of evenly spreading it around symbolizes how the equator evenly separates the hemispheres. A map showing Earth's surface features and elevations. Topographic map. A topographic map shows the shape and height of the land using contour lines. Imagine trying to navigate a crowded room at a party where you don't know anyone. Just like finding your way through the room requires understanding where people are clustered and where there's open space, reading a topographic map involves interpreting lines and symbols to understand the terrain's highs and lows. The people in the room are like the contour lines on the map. Where people are densely packed is like closely spaced contour lines indicating steep terrain, and open spaces are like widely spaced lines showing gentle slopes. The relationship between distances on a map and distances on Earth's surface. Map scale. Map scale shows how much smaller a map is compared to the real world. Imagine you're trying to fit a large wardrobe into a small car for moving day. This situation is quite similar to how a map scale works, because just as you need to understand the relationship between the size of the wardrobe and the space available in your car, a map scale helps you understand the relationship between the map's distances and the actual distances on Earth's surface. In this analogy, the wardrobe represents the actual distances on Earth. The car represents the map, and the ability to fit the wardrobe into the car is akin to how the map scale translates real-world distances into manageable, interpretable map distances. A system of satellites that enable the receiver to determine their location, global positioning system, GPS. GPS is a network of satellites that helps you find your exact location on Earth. Imagine trying to find your way in a massive, unfamiliar shopping mall without a map. Just like you would rely on signs or asking people for directions to locate a specific store, a GPS uses a network of satellites to help determine your position on Earth. In this analogy, the signs or helpful strangers are like the satellites, guiding you by providing the necessary information to navigate and pinpoint your exact location. Gathering information from a distance. Remote sensing. Remote sensing is the use of satellites or aircraft to collect data about the Earth's surface without making physical contact. Imagine you're trying to figure out what's for dinner without leaving your couch. This is similar to remote sensing, where scientists collect data about the Earth's surface without being physically present. Just like using binoculars to see what's on the dining table from afar, remote sensing uses satellites or aircraft to gather information about an area, allowing us to see and understand what's happening from a distance. The height of an object above sea level. Elevation. Elevation is the height or altitude of a place or object measured from sea level. Imagine trying to measure how high you are in a crowded elevator when all you see are floors passing by. This is similar to figuring out the elevation of a mountain, which involves knowing how high it is above a fixed point, like sea level, rather than just how many steps you've climbed. Just as you need to know where the ground floor is to determine your floor in a building, you need to know sea level to accurately measure an object's elevation. Difference in elevation between the high and low parts of an area. Relief. In science, relief refers to the variations in height and slope of the Earth's surface. Imagine trying to arrange a set of books on a shelf so that they all stand evenly, but some are taller and some are shorter. This is similar to how relief in geography describes the difference in elevation between the high and low parts of an area. Just as you notice the varying heights of books, relief highlights the varying elevations like hills and valleys in a landscape, where the tallest book represents the highest elevation and the shortest book represents the lowest elevation. A representation of the Earth's surface. Map. A map is a visual tool that shows the features and layout of an area, helping us understand locations and distances. Imagine trying to make a grocery list for a family dinner, but you can't write down every single detail about each item. Just like creating a simplified list of essentials to ensure you don't forget the crucial ingredients, a map simplifies and represents the complex surface of the Earth to highlight key features. The grocery list is to the full inventory of a grocery store, as a map is to the detailed expanse of the Earth's surface. Both serve as simplified, practical guides to help us navigate and understand something vast and complex. A map made by projecting lines from a globe onto a cone. Conic projection is a method in cartography where the Earth's surface is projected onto a conical surface, helping to accurately represent mid-latitude areas. Imagine trying to wrap a party hat around a small, round watermelon to decorate it. This is similar to how a conic projection works, as it involves fitting a flat surface, the cone, around a curved one, the globe, and then unfolding it to create a map. Just like aligning the cone's tip with the top of the watermelon and making sure the sides fit snugly around it, a conic projection aligns the cone with a specific latitude on the globe and projects lines outward to accurately represent areas on a flat map. The study of the shape of the land determined by elevation and landforms like mountains, rivers, and valleys. Topography. Topography is the study of the features and shapes of Earth's surface. Imagine trying to navigate your way through a cluttered room in the dark, where you have to step over toys, dodge furniture, and find your path without bumping into anything. This is similar to how topography describes the landscape, providing a map of the land's elevations and its features like mountains, rivers, and valleys, which influence how we travel across it. Just as you mentally map out the obstacles in the room to move smoothly, topography maps out the natural features of the Earth, guiding us through its physical highs and lows. A landform of flat land with low relief. Plain. A plain is a large area of flat or gently rolling land with few changes in elevation. Imagine trying to find a parking spot in a crowded parking lot where every space seems the same, with no distinguishable features to guide you. This is similar to a plain, which is a landform characterized by flat land with low relief, making it difficult to differentiate one area from another. Just as you navigate a parking lot by looking for small differences or landmarks to find your car, a plane requires you to rely on subtle changes or markers to identify specific locations, since its uniformity offers few natural cues. A flat raised landform with a nearly level surface. Plateau. In science, a plateau is an elevated flat area where a process or activity remains steady and unchanged. Imagine you're trying to improve your fitness, and after weeks of effort, you suddenly stop seeing progress, despite continuing your workouts. This situation is much like a plateau in geography, where a flat, raised landform maintains a level surface despite being elevated above the surrounding area. Just as your fitness progress levels off after initial gains, a plateau rises above its surroundings, but then maintains a steady elevation, illustrating how both scenarios involve reaching a new height, followed by a period of stability, without change. A natural land feature, like valleys, hills, or plains. Landform. A landform is a natural shape or feature on the Earth's surface. Imagine trying to find your way through a crowded room at a party, where each change in the crowd's density affects your path. This scenario is similar to how landforms like valleys, hills, or plains shape the movement of water, animals, and even people across the landscape. Just as navigating through denser or sparser areas of a crowd changes your direction and speed, natural land features like valleys guide rivers, hills redirect winds, and plains provide open expanses for travel, influencing patterns of movement and flow in nature.